Your hippocampus is shrinking right now. Not because of age, not because of some diagnosis, because of the way you're living today. And the stranger part, most of the habits destroying it are ones you'd never think to question. In 2011, scientists split 120 older adults into two groups. One group walked, the other did stretching. That's the entire experiment. A year later, they scanned everyone's brains. The walkers grew their hippocampus by 2%. The stretchers didn't. Theirs shrank, exactly as expected with age. 2% sounds small. It isn't. The hippocampus is where memory lives, where your ability to learn new things, navigate unfamiliar situations, and hold on to your own past comes from. It normally shrinks with age. These people reverse that with 30 minutes of walking, 5 days a week. Not a gym, not a supplement, not a protocol. Walking. The mechanism involves something called BDNF, brain-derived neurotrophic factor. Think of it as fertilizer for your neurons. Exercise floods your brain with it. More BDNF means stronger connections between cells, better memory formation, and more resistance to the kind of cognitive decline that doesn't announce itself until it's already happened. The threshold isn't high. Moderate aerobic movement done consistently is enough to change the physical structure of your brain. That's not motivational language. That's what the scans showed. Here's the one that surprises people most. You think you're recovering when you sleep. You're not. You're working. While you're unconscious, your brain is transferring everything you experience today into long-term storage. It's running a biological maintenance cycle, clearing out metabolic waste, regulating emotional circuits, rebuilding the attention systems you'll need tomorrow. One bad night disrupts all of it, not a week of poor sleep. One night of cutting it short impairs memory formation. Confirmed by a 2022 meta-analysis of dozens of studies. The effect is immediate and measurable. And here's what should change how you think about weekends. Sleeping in on Saturday doesn't fully reverse chronic sleep deprivation. The cognitive debt accumulates faster than weekend recovery can pay it back. Attention, working memory, emotional regulation, these remain impaired even after you feel rested. There's something else most people miss about sleep and emotion. The prefrontal cortex, the part of your brain that keeps your reactions proportionate, is especially sensitive to sleep loss. One night short and you're measurably more reactive, more impulsive, less able to read social situations accurately. The person who snaps at small things after a bad night isn't making excuses. Their brain is genuinely different. Your brain doesn't want more caffeine. It wants you to stop treating sleep like a negotiable variable. Everyone knows diet matters for the brain. Fewer people know this. A major clinical trial published in the New England Journal of Medicine in 2023 tested the MIND diet specifically. 604 participants, 3 years of follow-up. Not because what you eat doesn't matter, because the real story isn't about food. It's about blood pressure, blood sugar. Whether you smoke, your brain is one of the most metabolically demanding organs in your body. It runs entirely on oxygen and glucose delivered through blood vessels. Damage those vessels through uncontrolled hypertension, chronic inflammation, diabetes, and no dietary pattern compensates. The Lancet Commission on Dementia analyzed data from millions of people across decades. Their finding, approximately 45% of dementia cases are linked to modifiable lifestyle factors. Not genetics, not bad luck. Choices. The foods matter, but the vascular system they're protecting matters more. Most people have downloaded a brain training app at some point, maybe felt good about it. Here's what the research shows. Brain games mostly improve the specific game you're playing. Transfer to general intelligence, real-world memory, or everyday cognitive function is limited. You get better at the test, not at thinking. What does transfer? Learning something genuinely new. A language, an instrument. A craft that forces your brain to build entirely unfamiliar neural networks, not reinforce the ones already there. The active trial followed nearly 3,000 older adults through targeted cognitive training. Benefits lasted up to 10 years, but the key was genuine challenge, the kind that feels uncomfortable because your brain is actually building something new. Passive consumption doesn't do this. Watching, scrolling, listening, these feel like learning. They rarely are. The brain adapts to what you demand of it, and this works in reverse too. People who spend decades engaging with genuinely novel challenges show measurably different cognitive trajectories as they age, not because of any single session, because the accumulated demand of a lifetime of real challenge shapes what the brain becomes. This habit has some of the strongest evidence on the list, and it's the one least likely to appear on a wellness page. Social isolation predicts dementia risk, not as a side effect of depression, not as a vague correlation, as a direct measurable biological risk factor, placed by the Lancet Commission alongside smoking, physical inactivity, and hypertension. Here's the mechanism. Loneliness elevates cortisol. Chronic elevated cortisol damages the hippocampus. Isolation removes the cognitive stimulation that keeps neural networks active and connected. But there's something else worth understanding. Social interaction is cognitively demanding in ways that solo activities aren't. Reading someone's expression, following the thread of a conversation, managing your response in real time. These are complex operations that exercise multiple brain systems simultaneously. Isolation removes all of that quietly, every day. People who are consistently isolated don't just feel worse. Their brains age faster. This is the habit that requires no equipment, no routine, no expensive intervention. Sustained, meaningful contact with other people. That's it. Not all stress is the same. This distinction matters more than most people realize. Acute stress, the kind before a difficult conversation, a performance, a challenge you chose, can sharpen focus. Your brain mobilizes resources. Attention narrows. You're more present. Chronic stress works differently. Sustained cortisol elevation physically reshapes the prefrontal cortex, the region responsible for planning, decision-making, and emotional control. It compresses hippocampal volume. Over time, it doesn't just feel bad. It restructures the brain in the direction of reactivity and away from clarity. One more thing about chronic stress that rarely gets mentioned. The effects aren't always reversible. Prolonged stress can create structural changes that outlast the stressor itself. The brain that spent years under unmanaged pressure doesn't simply return to baseline when circumstances improve. Recovery is possible, but it takes time, and it requires the right conditions. Mindfulness and meditation have real evidence for stress reduction and emotional regulation. The more dramatic claims that 8 weeks of practice dramatically restructures neural architecture haven't replicated consistently, but reducing the sustained, unmanaged load of chronic stress has measurable downstream effects on memory, attention, and cognitive resilience. Your nervous system was designed for occasional challenge followed by recovery. Most modern environments deliver the opposite. Low-grade, continuous pressure with no clear endpoint. The system that evolved to handle a predator now runs on email, uncertainty, and financial anxiety indefinitely. The last habit has the most noise around it. Excessive screen use disrupts sleep, well supported. Constant notifications fragment attention in compounding ways. Heavy social media use correlates with worse mental health outcomes in certain groups, supported. Major structural brain changes from ordinary screen use in healthy adults, not in the data. The real issue is more specific. Your capacity for deep, sustained focus is not a fixed trait. It's a skill that degrades under constant interruption and strengthens under protection. Every time your attention is pulled mid-thought, there's a recovery cost. Small, but it compounds. Research on attention suggests that after a significant interruption, it takes an average of over 20 minutes to return to full focus on the original task. Most people never get there because the next interruption arrives before the recovery does. The question isn't how much screen time you have. It's whether you still have the ability to think deeply, without checking, without switching, without noise. The largest finding buried across all of this research: the finger trial, the active trial, the Erickson study, the Lancet Commission, isn't about any single habit. It's that combining them is what works. The finger trial ran 1,260 people through 2 years of exercise, nutrition, cognitive training, and cardiovascular monitoring. The cognitive improvements outperformed every individual component tested alone. This matters because most people approach brain health the way they approach dieting. Pick one thing, commit to it for a few weeks, see what happens. That's not how the brain responds. It responds to cumulative, sustained, multi-domain input. Change one variable, and the effect is modest. Change the whole environment, and the effect is different in kind. What the research shows, consistently, across decades of study, across populations, is that the brain responds to how you live, not how you optimize, not what you track or measure or supplement, how you actually live day after day, in ways that compound slowly enough to be invisible in the moment and undeniable over time. It's a life.